Hello, welcome back to the workshop. In a recent video that's been surprisingly popular, I converted this old drill press into a milling machine. It's been quite a useful tool. I actually use it just about every day. Where it sits now is temporary. I put it here so I could build it and so I could film that video, but it's up against the mini lathe, and I recently brought the Atlas lathe over into this area. It's just getting really tight. So I want to move this to its permanent location, and I want to build a dedicated stand for it. So that's what we're going to do in today's video. If that interests you, stay tuned. We'll get started. This is going to be the permanent location for the drill press mill. So I want to design that stand so it fits nicely in this location. I am going to relocate this cabinet, get it out of the way. That'll give me the height I need for the drill press. So here's kind of what I'm thinking for that design. I'll make this stand out of square tubing, fully welded. The top will match the dimensions of the base of the mill press. I'll make it the same height as I found that to be comfortable. The base will be wider than the top for stability. So I'm going to make this thing out of some 2-inch square tubing. This is 2-inch 1/8 wall square tubing. I'm going to start with the top. So I'm going to make the top the same dimensions as the base on the milling machine. So I'm going to take this outside. I'm going to use the chop saw and I'm going to cut it to length. Alright, so I got the top cut. I left the short side with the open ends. That way I can run the wires through for the VFD and for the contactor. So I'm going to take these, just clean them up with a flap disc, cut a bit of a bevel, and then I'll get them welded together. Once that's done, then we can figure out what we're going to do with the legs. So this is the top I just welded. I've laid out the legs kind of how I want them to be. Using a little math, this comes out to about a 9-degree angle. So I'm going to take the legs and I'm going to cut a 9-degree angle, top and bottom. And then I'm also going to cut a 9-degree on these braces, like so. And what I want to do is build 2 A brackets, one for each side, and then I'll stand the whole thing up and we can actually get the brackets aligned to the top. So I've got it laid out now. It's 39.5 inches corner to corner both sides, and 1 foot up from the bottom each leg. I think it's symmetric. So I'm going to take and tack weld it on the cross brace, flip it over, do the same thing on the back side, and then I'm going to bring the other leg over, lay it on top, and tack it. That way I know the 2 legs are the same. Once that's done, then we'll set it upright and we'll figure out the angles front and back. So I think the way I'm going to do it is I'm going to cut angles onto the side braces, put them in, and then square everything up with clamps, and then I'll final weld it. I'm going to have to fill in with weld up here. I didn't think about that until right now, but it's not going to be a significant gap, so I think we'll be all right. All right, so I've got it where I'm pretty happy with it. I clamped some 3/4 inch steel plate to the top. I wanted to make sure it was flat and everything was square, and it looks good. We're flat and square. So I'm gonna weld it up now fully, and then once I'm done with that, I'll flip it over, and I wanna show you guys what I'm gonna do with the feet. For some reason, I didn't record how I made the feet for the stand. I did these exactly the same way as I did on the Atlas lathe. I've decided to use some square plate. This square plate has a hole in the middle, and I've put a bolt through that with 2 nuts. And what I'm gonna do is I'm gonna capture this inside nut, flip it over, and weld it into the leg. And then I will be able to use the bolt and this second or lock nut to raise or lower the table. So here's how that turned out. I think it looks really good. I always say that. So I've got the welding all done. I think it looks really nice. I'm really happy with how it turned out. It's super stable. I think it's gonna be really strong. I would like to add some tabs so I can bolt it to the floor, but I don't have any weld tabs right now. So I'm gonna order some of those on eBay. When those get here, I'll weld those on. So now that that's done, I wanna paint it. I'm just gonna use the same gray Rust-Oleum paint that I've used on all my other machines. So let's slide it back out of the way. We'll get some paint on it. All right, I think that looks good for the first coat. This thing needs to dry overnight, at least 24 hours. So tomorrow, weather permitting, I'll put another coat on it. I'm really happy with how it's turning out so far. I think it looks pretty good. So it's been a couple of days. I let that paint dry overnight, and then I gave it a second coat, and I let that dry overnight. It looks really good. I'm super thrilled with the finish. I like the way the stand looks. Perfect. So the mill press is way too heavy for me to move assembled. I'd guess it probably weighs about 500 pounds. So to move it and put it on the stand, I need to completely disassemble it. So I'm going to disconnect the wiring. Let's get this taken apart and we'll move it over to the stand. So I'm going to mount the base plate to the stand. I'm going to drill some holes and just use some 3/8 inch bolts to hold it in place. I'm thinking probably 2 bolts on the short sides, 3 bolts on the long sides. I've got this section here where the column mounts. I can't put any bolts there, so I have to be careful about that. But otherwise, I'm going to grab a 3/8 inch drill bit and a mag drill. Let's put some holes in this. Alright, the yellow dots are where I'm going to drill the holes. I've got some mounting holes here I don't want to cover up, and I only have about 2.5 inches on the back. So I'm going to put a hole 3 inches from each corner all the way around. I may also do one in the middle here. I kind of forgot about that. So I'll lay that out. I'll mark one here. So that'll give me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 bolts. I think that'll be sufficient. So I put in 2 bolts. I wanted to hold the top firmly in place. I've been switching drill bits between drilling the base and then drilling all the way through the stand. So now I can drill the rest of the holes, then switch over to the longer bit and do the through holes. Alright, those are all good and tight. That's feeling pretty stout. So when I had the control box up top, I had offset the contactor switch because I had originally planned to put the safety switch on this side. Well, that didn't work out, and so the switch was off center. I wanted it to be centered here. So what I did is I drilled a hole from the top and I set it all the way to one side. Now when installed, the switch is centered. So I think I'm going to put the VFD on, temporarily put this back together so I can get the wiring all in the right spots, make sure everything's good. And then I'll take it apart again and I can move it over and get it set up in its permanent location. I couldn't find a good way to run the wires where they weren't in the way of the column or they weren't in the way of the table lock. So I gave it some thought. I decided the best way to do this, neatest way to do this, is to route those wires through the column. So I'm going to take this back apart. We're going to drill a hole through the base to route the wires. So I didn't like how the wires were going to come up along the back and be in the way of the lock for the table. So I got to thinking about it. I was going to make some external tubing to kind of protect the wires. And then I decided I've got the column, it's hollow. Instead, I might as well run the wires down through the column. So I need to make a hole in the base to allow the wires to pass through. I don't have a lot of space because of this 2-inch tubing. So I'm going to use a 2-inch annular cutter in the mag drill and drill it off center just to give me enough room to get wires down through the column and through the base. That looks like it's going to work out pretty well. So this is the drop. This is the one that goes from the 240 in the ceiling down into the contactor. I've got to make a new one that goes from the contactor up to the VFD. The one I have is just too short. So I'm going to bring the VFD in, I'm going to get it set up here, and then we can see how much wire I need. And I'll get this all routed, kind of show you how it works out. So you're looking at where the wires come out of the top of the column. This particular drill press has an attachment for a 2-speed drive. I don't have that attachment, but it has a mount that helps support a belt guard. What I'm going to do is use a couple of those cable retainers, run the cables up and over this, and that will hold them in place and protect them from the belt. Alright, so I've got it wired up. I'm really happy with how it's turned out. All the wiring runs through the central column and then down into the switch box. This wire here goes up to the ceiling. This is the 240 volt drop from the ceiling. And then the other wiring goes to the VFD. And I'll bring you around and show you that. You're looking at the back side of the VFD. This is the wire that comes up from the switch box. So this carries power up into the VFD. I've routed it such that it runs over and around the belt. There's plenty of clearance here. I don't think I'll have any trouble with it contacting the belt. And then it runs down in and into the VFD. All right, let's put the motor on. There's a lot of slack in that belt. Well, let's try it. I'm going to switch belts. Since I mostly just use it in this uppermost pulley position, I decided to install a shorter belt so that I don't have so much weight hanging off the back. I had that longer belt. It was a 43 or a 4L450 in here so that it would accommodate the largest pulley. But I don't use this. I haven't used it since I've got the VFD. That is heavy. All right, everything's back together. There's only collets in my parts box here, so I think we're ready to go. I've got it wired in. The 240 comes in, drops. You've seen everything else, so let's fire it up. I want to make sure it spins, let it warm up. All right, VFD is on. I'm going to pick right in the middle of the RPM band. It feels really nice. It feels really good and smooth. All right, well, let's let it warm up and then we'll make something with it. I have this column cap that I had 3D printed and it won't work now because it needs slots cut out for the wiring. So I think instead of 3D printing another one and then mill out slots here for the wiring, and that will give us, a nice finished column cap that won't let chips get in there. Here's a better look at how that fits. It did a really nice job cutting that plastic, but of course it did. It's plastic. So the next thing I want to do is try it on some aluminum. This is a cylinder head for a two-stroke Chinese scooter. This one's pretty beat up. It was really poorly packaged in shipping. What I want to do is set it up in the rotary table, and I want to cut an O-ring groove in this surface. So instead of having to replace gaskets every time I remove this, it's O-ringed and I can just replace the O-ring. I spent an hour trying to get this thing centered around the spark plug hole before I took out calipers and measured, and it's actually egg-shaped. So I drove myself crazy, but this is as good as I can get it. So I'm going to start by cleaning up this inside diameter. So I'm going to run that around and then I'm going to reposition it and we'll cut the O-ring groove. And I'm using a 1/8 inch end mill here. It took me about 15 minutes to machine the cylinder head. So that you guys can see the whole thing, I've sped up some of it. Alright, so that's the inside. Now I'm going to reposition it and I'm going to cut the O-ring groove, maybe about 3 millimeters off this center edge. I'm going to do a really light pass at first so I can make sure I didn't screw anything up. I've got to get an O-ring the right size so I can check it out and make sure it fits, but it sure looks good. That went really well, I think. I've got a couple of these blanks. These are what came out of the base when I drilled the holes for the wiring and for the worm gear actuator. These are really gummy hot rolled steel. I don't know exactly what they are. What I want to do is clamp one up here and mill off this lip. So this is what was left when the cutter came out the bottom. This is the part it couldn't cut. So I want to mill that off and I want to see how it does. So I'll probably set this up to remove about 1 millimeter of material and we'll just work our way across and remove that lip. It took 11 minutes for me to mill the face off of this. I'm going to speed it up. I'm really happy with how this turned out. The stand is really nice. It fits the style of the drill press well. It's sturdy, it's rigid, and I couldn't be happier with it. It's nice to have the mill over here by itself, away from all the other stuff. And I've got easy access. I couldn't be happier with this. The mill seems to be working really well too. I mean, you saw what it did. This is hot rolled steel. And the surface finish isn't stellar, but you know, for a home shop type mill, I think that did just fine. So if you're subscribed to my channel, I want to say thank you. I really do appreciate it. I enjoy reading the comments, seeing the discussion. Thank you so much for that. If you're not subscribed and you enjoy stuff like this, I put out videos just about every other week. I try to do it more frequently than that, but some of these videos take a really long time to make, especially if I have to build something in the process. So if you're not subscribed and you enjoyed this, well, consider subscribing. So with that, I hope you enjoyed watching. Thank you.